One application of matrices is code theory or cryptography. So we can use matrices to encode and decode messages. For example, let's encode the message math using the matrix M, which is 2411. So to do that, we want to find the number that corresponds with each letter, just using a simple substitution where 1 is A, 2 is B, 3 is C, and so on. So the letter M corresponds with the number 13, A corresponds with 1, T corresponds with 20, and H corresponds with 8. And we're going to write these letters in a 2x1 matrix, or in a series of 2x1 matrices. So MA will be 13, 1, and TH will be 28. Now already this message is a little bit encoded, but it would be really easy to break this code just seeing that we could put in letters for the corresponding numbers. So we want to use a matrix in order to encode this message, make it a little bit messier. And thus it would be easier for us to send the message without it being decoded. So now we're going to multiply each column by the matrix M. So with the first column, we're going to multiply 24 by 13, 1. 2 times 13 is 26, plus 4 times 1 is 4. 26 plus 4 is 30. And then we multiply 1, 1 by 13, 1. 1 times 13 is 13. 1 times 1 is 1. 13 plus 1 is 14. And now we do the same with the second column. We're going to multiply it by 2, 4, 1, 1. So we get 2 times 20 is 40, plus 4 times 8 is 32. So 40 plus 32 is 72. And then 1 times 20 is 20, plus 1 times 8 is 8. So the second part of our encoded message is 7228. So the encoded message that we would send is 3014 and 7228. So the matrix jumbled this message, thus making it more difficult to break the message. But how would we decode this message if we were the one receiving it? So if we were to keep decoding this message, we would assume that we had the matrix M that was used to encode the message, or some information to give us the matrix M. And to decode the message, we need to find M inverse. So to find M inverse, we're going to use the inverse equation, which is 1 over AD minus BC. Then we switch the right diagonal and change the signs of the left diagonal. So to decode the inverse matrix in this case is going to be 1 over A times D is 2 minus B times D is 4. 2 minus 4 is negative 2. And then 1, 2, negative 4, and negative 1 along the right and left diagonals. So that means M inverse is negative 1/2 to 1/2 negative 1. So to decode our previously encoded message, we're now going to multiply M inverse by each column. So the first part would be M inverse times 30 and 14, which would give us Negative 1/2 times 30 is negative 15. Plus 2 times 14 is 28. Then 1/2 times 30 is 15. And then negative 1 times 14 is negative 14. So this first decoded part of the message is 13:1. Second part of the decoded message, we're going to take M inverse again, and this time multiply by the second encoded column, which is 7228. So that would be negative 1/2 times 72 is negative 36, and 2 times 28 is 56. And then 1/2 times 72 is 36. Negative 1 times 28 is negative 28. Simplifying here, we get 20 and 8. So you can see that we do get our original columns back, which were 13:1 and 28. So after seeing this decoded message in numbers, we'd switch back to letters. So 13 goes with M, 1 goes with A, 20 is T, and 8 is H, and we get the message back, which was math.